Good evening, students, and today we will discuss about a few problems based on the second chapter of class 12th. See, the figure shows the three equipotential surfaces and their surroundings. The given charge Q, T1, T2 be the distance between them, and what is the relation between T1 and T2 they ask. Now, see, from here to here, if you take R, you can write V1 equals to this V1 equals to, we can write as KQ by R. And V2 equals to, we can write from here to here, says KQ by R plus T1. And V3, if you want, we can write KQ by, from here to here, it is R plus T2. Otherwise, R1 plus T1 plus T2. Okay. First one, KQ by R, if you take, the given as it is 60 volt. And the second voltage, they given as 40 volt. And this is given as 20 volt. So mark it as this is equation number 1, this is equation number 2, and this is equation number 3. Okay. Now see, if you take the ratio between equation 1 and 2, this is 60 by 40 equals to, it becomes R plus T1 by R. This is 20, and this is 3, and this is 2. Do the cross multiplication, 3R equals to 2R plus T1. So from this R1 we can take, see the T1 value here, how much it is? VR is equals to 2R plus 2. Then T1 is equals to, we can write 20 by T is equals to R by T. Then if you take this is 3R, that is 2R plus 2T1, this is it. Okay. Then it becomes T1 equals to, we have the formula R by 2. This is T1. Now again, if you take the second equation and third equation, if you take second equation, first equation, and third equation, if you take, this is 60 by 20. We can write KQ by R. And this is KQ by R plus T1 plus T2. Yes. And this also becomes once, and it is as KQ get cancelled, becomes 3R equals to R plus T1 plus T2. Okay. Now this 3R equals to 3R minus R. 3R minus R equals to T1 plus T2. 3R minus R becomes 2R equals to T1 plus T2. Then T2 equals to 2R minus T1. So we can write T2 equals to how much it is? T2 equals to 2R minus T1 is R by 2. This is 4R minus R by 2. It becomes 3R by 2. So T1 is R by 2, T2 is 3R by 2. So answer is T1 less than T2. T1 less than T2. Okay. So take three equations. From the three equations, we can write in the three different ways. And first we can find out T1 value. Later we can find out T2 and T1 relation. Then use the relation. Okay. Now see, n small mercury drops of same size charged to the potential V. Each they are collapsed to form a single drop. Single drop. Spherical drop means So total charge you can replace Q is equals to N times of Q. In spherical capacitor means we have big capacitor means C is equals to 4 pi epsilon naught R. Okay. And in this case, the total volume is remains constant. So 4/3 pi capital R cube equals to, this is the big single drop. This will form because of n small droplets. So we can write n into 4 by 3 times the pi small R cube. This 4 by 3 pi, 4 by 3 pi get cancelled. Then R equals to n power 1 by 3 times of small r. This is the relation between capital R and small r. So we can write this is equals to 4 pi epsilon naught small r into n power 1 by 3. So it becomes, this is capacitance of the big drop. This is the charge of the big drop if you type it. This we can written as n power 1 by 3 times of Cs. Now they ask potential. We know the formula Q is equals to Cv. So V equals to Q by C. So V big equals to Q big by C big. Cube is equals to n times of cube. This is n power 1 by times of Cs. This is n power 1 minus 1 by 3 times of C. This is okay. This is Q by C. If you take Q by C is equals to, this is Q by C. Small q we can take. This is small q by C. So this is nothing but potential. So it is answer 2 by 3 times the potential. So option 4 is the correct answer. So this relations is important, and the charge relation is this. If they ask capacitance, this is the relation. And if they ask potential, potential of the big drop is equals to n times of 2 by 3 times of potential of the small droplet. Okay. Now let's see the next problem here. 4 capacitors are connected in series. So 4 are identical capacitors are connected in series. The given here potential is given as 0 volt. Grounded means your potential is equals to 0 volt. Okay. So whenever we connect it to the ground, there the potential is equals to 0. So all are identical capacitors means the potential is equally sharing here. Means here 2.5, here 2.5 volt, here 2.5 volt, here also 2.5 volts. Okay, out of 10 units, so we have here 10 minus 7.5. So remaining how much here? 2.7 volts. But we want potential here 0 means the potential is equals to how much here? 7.5 volts only. Okay, we want to become it is a 0. So if you store here 2.5, 2.5, 2.5, total how much? 7.5. Here also it becomes 2.5 is there, but we want here potentially 0 means here we want minus 7.5. Otherwise this, so answer is 7.5 volts here. Okay. Now see here, the next problem. So we have three potentials here, 20 volts, 30 volts, and 40 volts. These three are the three equipotential surfaces. Yeah. Now here, the difference between these two, if you take delta V is equals to 10, here also delta V is equals to 10 volts. Here also 10 volts. Now they ask a charge is passing. So work done to move a charge formula delta V into Q. This is the formula to find out work done. Okay. Now, work done to move a charge from A to B. It is independent of the angle. Here, this is 10. Charge they given as 1 Q. So it becomes 10 Q. Okay. And similarly, work done to move a charge from B to C. That is equals to potential difference between B and C into charge. What is the potential difference between these two? 30 minus 40, it becomes 10 volts only. So WBC equals to how much? 10 into cube. Now see the two equations. Here also 10 cube, here also 10 cube. So then the work done to move a charge from A to B is equals to work done to move a charge from B to C. So what is the correct answer here? Option 4 is the correct answer. Yeah. Now, so coming to the next problem. So whenever they given this kind of problems, we have to check whether the potential difference is same or not. In both the cases, potential difference is same means if you move same charge, work done also same. Yeah. Next, we have a proton accelerating by 1 volt. Then its kinetic energy we have. So we have the relation. Work done is nothing but change in kinetic energy. So work done formula V into Q. This is nothing but change in kinetic energy. Okay. So work done is equals to. So I want kinetic energy. Kinetic energy is equals to V into Q. Q means proton charge is E. 1 and this is 1. So answer is 1 electron volt. So this is an important relation. A is equals to EQ. Okay. Then after, see the next problem. A bullet of mass 2 kg. This is mass. And charge they given as this is charge 2 micron. So the potential difference must be accelerated from the rest. From the rest means initial velocity 0. Equal to speed 10 meter per second means this is the final velocity. Okay. So we have in class 11 work kinetic theorem. Work done is equals to change in kinetic energy. Now they ask your potential difference. You can use the concept of work done is equals to change in kinetic energy. That is equals to delta V into Q we can write. So work done is equals to change in kinetic energy means your initial velocity 0 half m into v square minus u square equals to, they ask delta V, we can write delta V into charge. Charge they given us 2 millicoulomb they given. Yeah. So half mass they given as 2 kg, initial velocity 0, final velocity 10 square means it is 100 equals to delta V into 2 into 10 power minus 3. So this 2 and this 2 get cancelled. This is ones, this is 50s. So delta V is equals to 50 by 10 power minus 3. That is equals to 50 into 10 power minus 3 plus 3. This is, so this is nothing but 50 kilovolt. So option 2 is the correct answer. Option 2 is the correct answer. Okay. Now here you see this problem, the given one circuit diagram, 2, 2, and this. Now see if it is P, this is Q, this is R, this is S. P by Q is 2 by 2, R by S is 2. So all are equal capacitors means we can write an equivalent diagram like this. Yeah. Now see, after that, they given one diagram of this. Yes. 2, 2, 2, 2, 1, 1. Okay. So otherwise we can write these 2, 2, 2, 2, and 2, and 2. And these two are parallel, so it becomes 2 microfarad. So after that, it is 2 microfarad. Yeah. This is Q, this is 2 microfarad, this is P. Okay. This is 2, this is 2, this is 2, and this is 2. Okay. 2, 2 series means it becomes 1. 2, 2 series means it becomes 1. And 1, 1 connecting in parallel, it becomes 2. So this is 2, and this is also 2. 2, 2 series, it becomes 1 microfarad. Okay, clear? So these two are in series. and these two are in series. Series identical capacitors means capacitance value by number of capacitors we should take. Okay? Then the equivalent capacitance is equals to 1 microfarad. Okay? Next, see the next problem. Here, in a certain space, potential they given, they ask what is the field. We have the formula E equals to minus dV by dx. Okay? Then this E equals to minus d by dx of 8x square plus 2. 2 is a constant differentiation becomes 0. So 8 2s are 16. So E is equals to minus 16 into x. What is x value here? Then E equals to minus 16 into 4. This is given as minus 4. So 16 fours are 64 volt by meter. 64 volt by meter. So we have a relation. This is an important relation to find out the electric field when the given potential. We have to do the differentiation. If they give electric field, they ask potential means we should do integration. Now, see the next problem. This is one capacitor C1, this is one capacitor C2, and this is. So here we can take this is V1, and this is V2, and this is V3. Now they ask what is the potential at this point. A simple thing, multiply these two, multiply these two, multiply these two. So then V0 is equals to, if you multiply these two, C1, V1. If you multiply these two, C2, V2. If you multiply these two, C3, V3 by, add all the capacitors, that is C1 plus C2 plus C3. So what is the answer here? Option 2 is the correct answer here. Okay. Now the next problem is see a metallic halo metallic sphere. This is important. Halo metallic sphere radius 10 centimeter and the surface they given as 10 volt. The potential at the center of the sphere inside V inside is equals to V on surface. In case of hollow spheres, we know whatever the potential is there on the surface, from the center to the surface, it is remains constant. So answer is 80 volt only. Okay. So answer is 80 volt. Next one. Now see, take this is B, this is Q, this is R, and this is S. Okay. P by Q means 1 by 3 equals to 2 by 6. This is also 1 by 2. This is a balanced Wheatstone bridge. This is balanced Wheatstone bridge. Now this circuit we can rewrite like this. 1, 3, 2, and 6. This is 1 microfarad. This is 3 microfarad. This is 2 microfarad. And this is 6 microfarad. Now this 1 and 3 connected in series. Okay. These two are connected in series. Series formula we have C1, C2 by C1 plus C2. This is series formula. Okay. And this becomes, I'm taking this is C1. C1 is equals to 3 into 1, 3 by 3 plus 1, 4. And I'm taking this is C2. This is for series combination. Okay. Then C2 is equals to 2 into 6. By 2 plus 6, it becomes 8. 2 ones are, 2 fours are, 2 threes are, 2s are. Okay. Now, equivalent capacitance. Now, these two are connecting in parallel. So, what we get the answer here? 1 into 3 by this are series 1 into 3 by 1 plus 3, 4. These two are in series. So, becomes 2 into 6 by 2 plus 6, 8. 2 ones are 2 fours, then upward. Then we can add 3 by 4 plus 3 by 2. So LCM is 4 here. Okay, this is 3, but this is 6. So answer is 9 by 4 microfarad. So option 1 is a correct answer. Okay. Then after see this diagram, so they are connected here. This is A, this is B. Means half of the distance. This is A, this is dielectric. So A dielectric constant is 1. You take this is 2. When the area is divided, this is C1, this is C2. So C1 and C2 are in parallel. So parallel formula we have CAB equals to K1 plus K2 by 2 into C. Okay. So CAB equals to K1 is 1, K2 is 5 by 2 into 6. Okay. So CAB equals to become 6 by 2 into C. So CAB equals to 3 times of C. Okay. This is C. So that's all for today. Thank you very much. Have a nice day. Good night.